So in order to use pivot and to measure the acceleration of a car, I need a video. And if you look, I've made attachments to the bottom of the laboratory that we're running. The first one's called acceleration of a car, and can you download it? This puts it onto your computer so that when you open Pivot, you can actually analyze that. And so we're going to start using Pivot and the activity called HPHS motion of a car in order to analyze its acceleration. If I click on the laboratory, up pops the lab with many boxes for me to fill out. But there are 3 experiments: an acceleration, a car decelerating, and a car at constant velocity. We're going to come back to this in a minute. I'm going to open up the pivot activity called motion of a car, and there are 3 sets of boxes that allow me to figure out acceleration, deceleration, and constant velocity. In order to upload the movie to Pivot, I'm going to choose File, and then go to my Downloads folder on my Chromebook so I can find the movie called Acceleration of a Car. I'm going to hit Open, and notice that now the title of the movie is right here to the right of the Choose File button. Once I have that, I need to hit the Update button in order for Pivot to put the movie in the tool package. Once I see the movie of my son with a stick here, I can start analyzing it. So if I play the movie, I see a car start on the left and accelerate to the right. That is the car that we are going to measure. But a bit of information is given to me in the first 1 second of the movie, and I'm told that this is the calibration distance, 3.0 meters. Pivot needs to have a known displacement in order for the tools to work. So I'm going to open up this tool package, and this first icon is called the calibration icon. I get this arrow, and then a box in the bottom left-hand corner that says calibration distance. I'm going to take the left side of the arrow and put it here in the yellow box. And I'm going to take the right side of the arrow and put it here in the yellow box. And now I'm going to tell Pivot that this distance is 3.0 meters. Once I hit Update, all of the tools become available to me on Pivot. And this first tool is the displacement, or a meter stick. And I can grab it and move it around, but I'd like to line it up with this post right here. Another tool I can get out is the timer. And I'm going to move it out of the way so it doesn't get in the way. And what I'd like you to do is, there's a car right here that's about to turn right. Can we advance the film so that the car just begins to go around the corner and begins to pass that post? I'm going to put the meter stick right on the front bumper. At this point, I have some information that I can put in my laboratory. I know the calibration distance and the color of the car. So as I open up my laboratory, calibration distance used for Pivot, that was 3.0 meters. And if I look on the movie, I can see that the car is gold that we are end up going to be measuring. The next box asks for total time, and this is where Pivot comes in. So I have that car, and I've lined up my meter stick right with the front bumper, and my timer has a number on it, but I want to zero it. So I zero that. So at 0 meters, it reads 0.0000 seconds. The question is, how much time does it take the car to go from here to over on this side of the film? And why don't we measure so that the front bumper just crosses the 12-meter mark? Can you make that measurement and then check against mine? So when I get the front bumper of that car to just barely cross the 12, I read 2.8000 seconds. Can we use that information? So this is the total amount of time it took the car to go from the beginning to 12 meters, 2.8000 seconds. Now this yellow box is the initial velocity, or how fast was the car going in the beginning. It asks for a displacement and a time. Well, we're going to use pivot again. I'm going to rewind my film so that the front bumper is just barely touching the 0 meter mark, and then I want to know how much time it takes to go between 0 meters and let's say 1 meter. Can you measure the amount of time between 0 meters and 1 meter? Why don't you give it a shot and then check against mine? When I do this activity, I see that at 0 meters I have 0 time, and then it takes the car 0.3000 seconds for the front bumper to hit the 1 meter mark. Can I add that to my data table? So in the beginning, the velocity, the displacement between 0 and 1 meter is 1 meter. And the amount of time it took for that to happen is 0.3000 meters. And now it asks for initial velocity. And the velocity equation says displacement divided by time. Can you make this calculation and then check against mine? When I do this math, I get 1.00 divided by 0.30. And I get an answer of 3.333 meters per second. So that takes care of initial velocity. Can I use pivot to find final velocity as well? So this is the velocity in the beginning. What about between 11 and 12 meters? That's how fast the car is going in the end. So I'm going to advance the film so that the front bumper just barely passes the 11 meter mark. And then I'm going to hit my reset again. How much time does it take the car to go from 11 meters to 12 meters? Why don't you give it a shot and then check against mine? When I do this activity, I find that it takes the car 0.2000 seconds to travel between the 11 and the 12 meter mark. Can I add that to my final velocity? So the displacement between 11 and 12 meters, that was 1.00 meters again. And it took the car 0.20 seconds for it to travel that displacement. How do I figure out final velocity? Velocity is displacement divided by time. Can you make this calculation and then check against mine? And so I'm going to type 1.00 divided by 0.20. And I get the number 5. 5.00. And so now I have a final velocity, how fast the car was going at the end. I have an initial velocity, how fast the car was going in the beginning, and the amount of time between one and the next. These things are going to help me for the acceleration. And the acceleration formula is velocity final minus velocity initial divided by the amount of time. So if I replace numbers for letters, the velocity final is 5.00 minus 3.33. I'm going to hit equals, and then I'm going to divide by 2.80 because that's the amount of time. Can you try this calculation and then check against me? So when I do this math, I'm going to put 5.00 minus 3.33, and I'm going to hit the equals button. And then I'm going to divide by 2.80 to get my acceleration of 0.596 meters per second squared. Good job.